Inflation is a phase of extremely rapid growth that occurred when our universe was incredibly young. After that, inflation stopped, and the Big Bang filled the cosmos with radiation and particles. Then, as the cosmos cooled and expanded, the density of that matter and radiation decreased. When matter eventually converged, it formed stars, galaxies, and clusters. Nevertheless, recent findings imply that a crucial component, primordial black holes, might be absent from this straightforward tale. Presently, we only know of one surefire mechanism to produce black holes. It is achieved through the death of large stars. They attain high enough densities when they terminate their existence and collapse in on themselves, outpacing all other forces and causing the creation of a black hole. Yet, the early universe might have been unusual enough to produce black holes on its own terms. The process of the universe cooling down after inflation ceased was not a painless one. Instead, there were huge movements of mass and energy that were quite violent. It's possible that regions of the universe have suddenly grown dense enough to spontaneously generate black holes without first going through the process of star formation. These are what are referred to as primordial black holes. The total number of primordial black holes in the early cosmos was severely constrained by cosmological measurements. Yet, there is still room for them. In addition, a group of experts has written a paper that examines an unanticipated result of the creation of these primordial black holes. Black holes are not wholly black, as Stephen Hawking's research has shown. They actually have a faint glow due to a rare quantum phenomenon called Hawking radiation. This is a rather ineffective procedure for black holes of average size. Only one radiation particle typically escapes from a black hole per year or so. Smaller black holes, however, give off a lot more radiation. When the universe was still in its infancy, if the primordial black holes were small enough, they would entirely vanish, leaving no evidence of their existence. Yet the researchers discovered that this creates a peculiar circumstance. These primordial black holes release their own radiation and matter as they dissipated. If enough early black holes vanished, the density of matter and radiation might remain constant despite the universe's expansion. In such situations, the evaporation of primordial black holes has the ability to put the cosmos into a long stasis where the abundances of matter and radiation are absolutely constant, notwithstanding cosmological expansion. This unexpected phenomenon may open up new perspectives on the dynamics of the early universe and result in distinctive signatures of the evaporation of such strange objects. The rest of cosmic history would proceed without the primordial black holes eventually when they all vanished. They would, nevertheless, leave their imprint. Potentially enduring effects from the changes in matter and radiation density may be discernible even today. Moreover, gravitational waves may still exist today because to the primordial black hole's self-initiated process of dissipation.